Hello everyone, and welcome to the next video on relationships between two quantities. In this video we will get a chance to review the four basic relationships and also try a few practice problems. As far as terminology goes, you can think of the word direct as meaning that similar changes happen to the values of the quantities, and the word inverse means that opposite changes happen to the values of the quantities. Similar and opposite, depending on the context, can mean different things. Sometimes what we mean by similar changes is that the value of both quantities increase or the values of both quantities decrease. At other times, similar changes may mean that the size of the quantities increase or their sizes decrease. The word inverse means that opposite changes happen to the values of the quantities. For example, one increases in value, the other decreases in value. Keep in mind that these changes do not have to have the same size or be related in any way other than being either similar or opposite. Now, when we talk about superposition, we imply that the changes in the values of quantities happen through addition and subtraction. And also, you hear that we use the words increase, decrease, and the word amount. So we say that the value of one of the quantities increases by a certain amount, or the value of one of the quantities decreases by a certain amount. The word proportion is used to refer to the fact that the changes happen through multiplications and divisions. And in this context, we talk about scaling the value of a quantity by a factor. Now you might wonder, why is it that we use the word scale for proportion but increase decrease for superposition? As an example, when we add a number, the value increases. Or does it? Because you could add a negative number, which means that the value decreases. But supposing you have simplified your signs, then adding a number increases its value and subtracting a number decreases its value. However, with multiplication, multiplying by a number does not necessarily increase the value, and dividing by a number does not necessarily decrease the value. As an example of this, suppose Q1 is 5 and Q2 is 8, and now we multiply both of them by 3. So 5 becomes 15 and the value increases, of course, and 8 becomes 24, and again the value increases. So in this case, it appears to be true that if we multiply the values of two quantities by the same number, both values increase. But take a look at this scenario now. Q1 is 5, Q2 is negative 8. And if we multiply both of them by the same number, 3, 5 increases in value, but negative 8 decreases in value. And that explains why we do not use the words increase or decrease with proportion. Increasing or decreasing a value in the case of superposition happens through additions and subtractions. So we add the same amount to both quantities. We subtract the same amount from both quantities. Sometimes we may add a certain amount to one quantity and subtract the same amount from the other quantity. So they both may get added. You may subtract the value from both, or you can add a value to one of them and subtract the same value from the other one. For proportion, scaling means that you either multiply the values by a number or divide the values by a number. So for example, you may multiply the values of the two quantities by 5, or you may divide the values of the quantities by 5. You may multiply the value of one quantity by 5 and divide the value of the other quantity by 5. Now, as far as the equations and the properties of the four basic relationships go, for direct superposition, how do you identify that an equation expresses a relationship of type direct superposition, you compare it to either the standard form of the direct superposition relationship, which is Q2 equals K plus Q1, or the conservation form, which is Q2 minus Q1 is equal to K. Now, I have talked in detail about these equations in the previous videos, and so I won't go into any kind of detail, but use this as an opportunity to sort of summarize the process of identification and also getting information from equations of type direct superposition, inverse superposition, direct proportion, and inverse proportion. So if your equation looks like either of these two, then what you're dealing with is a direct superposition relationship. And then right away you can make some conclusions. Two conclusions, in fact, you should be able to make right away. One is that for direct superposition, the values of the two quantities increase or decrease by the same amount. They both go up by 5, they both go down by 10, and so on. And also that the difference between the values of the two quantities is constant, which is pretty much what the conservation form of the equation says. For inverse superposition, you compare the given equation to Q2 equals K minus Q1, which is the standard form, or Q2 plus Q1 is equal to K, which is the conservation form. The two things to conclude: one, an increase or decrease in the value of one quantity is matched by a decrease or increase in the value of the other quantity. So one quantity increases, the other one decreases, or one of them decreases, the other increases. And these things happen by the same amount. And also from the conservation form, we can say that the sum of the values of the two quantities is constant. For direct proportion, the two equations are Q2 equals K times Q1, which is the standard form, or Q2 divided by Q1 is equal to K, which is the conservation form. The two things to conclude: the values of the two quantities get scaled by the same factor, and that means they both get multiplied by 2. So the word scaling means that you either multiply the value by a number or you divide it by a number. So they both get multiplied by 2, or the values, both of them get divided by 5, and so on. And from the conservation form, we can say that the quotient of the values of the two quantities is constant. For inverse proportion, the equations are Q2 equals K over Q1, which is the standard form, or Q2 times Q1 is equal to K, which is the conservation form. The two things to conclude: the value of one quantity is scaled by a factor, so it's multiplied by a number like 4, while the value of the other quantity is scaled by the inverse of that factor, gets multiplied by something like 1 over 4. So one of them becomes 4 times larger, the other one becomes 4 times smaller, and so on. And from the conservation form, we can say that the product of the values of the two quantities is constant. Okay, these relationships are summarized in the table here. We have the relationships listed on the left side, then the standard form of the equations for them, and the conservation form. Okay, we're going to keep this table here, and now we're going to take a look at a few examples. I will start with one example, and then I will give you a few practice problems to work on. Okay, so in this example, now I've made the problem a bit shorter so that I can fit it in this area. So some of the stuff I will tell you about. The problem says identify the relationship between the quantities amount of money saved and amount of money spent in the formula below. What conclusions can you make based on this classification? And the formula is amount of money saved is equal to 60,000 minus amount of money spent, where $60,000 represents annual income. This is inverse superposition. the relationship between amount of money saved and amount of money spent is inverse superposition. I know that because this equation is similar to the standard form of the equation for inverse superposition, with amount of money saved being the same as Q2, 60,000, which is a fixed value, is K, and then we have subtraction of Q1, which is amount of money spent. What this means is, number one, an increase or decrease in amount of money spent, that's Q1, is matched by a decrease or increase in amount of money saved, which is Q2. So if I spend, let's say, $50 less, then my savings will go up by $60. And that the sum of amount of money spent and amount of money saved, that would be the sum of Q2 and Q1, or Q1 and Q2, is the annual income. It's a constant, which is $60,000. All right, now 6 problems will follow, and you can try them. After I pose the problem, pause the video and come up with the type of equation that you have, as well as the 2 conclusions that you can make. Here's problem number 1. Identify the relationship between the quantities, the empty volume, and the volume of water in the formula below. What conclusions can you make based on this classification? The empty volume is equal to 1.5 minus the volume of the water. 1.5 liters represents the volume of the jar. So the problem is that we have a jar. Inside this jar, which has a fixed volume, 1.5 liters, we have some water. And of course that water occupies a bit of a volume. And the rest of the jar is empty. And this is the relationship between the volume that's empty and the volume of the water. The empty volume is equal to the volume of the jar minus the volume of the water that's in it. Okay, see if you can identify the type of relationship between the empty volume and the volume of the water and make the 2 conclusions. This equation is similar to the standard form of inverse superposition, with Q2 being the same as the empty volume. The K, which is a constant, is the fixed volume of the jar, and Q1 is the volume of the water. What this means is that an increase or decrease in the volume of the water in the jar is matched by a decrease or increase in the empty volume. So if I put, let's say, half a liter more of water into the jar, then the empty volume goes down by half a liter. And that the sum of the volume of the water and the empty volume is the volume of the jar, which is 1.5 liters. That conclusion comes from the conservation form. The sum of the 2 quantities is constant. And in this case, the sum of VE and VW will be fixed, 1.5. Here's problem number 2. Identify the relationship between the quantities, amount of money spent, and number of pens in the formula below. What conclusions can you make based on this classification? Amount of money spent is equal to 1.18 times the number of pens bought. $1.18 per pen is the price of a pen. So basically you buy a number of pens, each one is priced at $1.18, and A is the amount of money that you spent, the total amount of money that you spent. Now see if you can relate amount of money spent and the number of pens bought and make the 2 conclusions. The relationship is direct proportion, and I know that because the formula has the same form as the standard form of the equation for direct proportion, with Q2 being amount of money spent, K, which is a constant, is the price of a pen, which is fixed at $1.18 per pen, and N is similar to Q1. This means that scaling the number of pens by a factor, that means buying twice as many pens, or half as many pens, or 3 times as many pens, forces the scaling of the amount of money paid by the same factor. So if you buy twice as many pens, you pay twice as much. If you buy half as many pens, you pay half as much. You buy 3 times as many pens, you pay 3 times as much. So this would be a fancy way of saying all of that. Scaling the number of pens by a factor, multiplying the number of pens by a number, forces the scaling of the amount paid by the same factor, forces the multiplication of amount paid by the same number. And that the quotient of amount paid to number of pens is constant, equal to the price of the pen, which is $1.18. This comes from the conservation form. The second conclusion here always comes from the conservation form. The ratio or quotient of the two quantities is constant. And in this case, the ratio becomes A over N. So you're dividing the total amount of money spent by the total number of pens, which of course gives you the price of a pen. Here's problem number 3. Identify the relationship between the quantities pressure and volume in the formula below. What conclusions can you make based on this classification? P times V is equal to 45,000. 45,000 joules represents the internal energy of the system. Now, as I mentioned in an earlier video, this equation it relates to a system that consists of a gas inside a container, with P being the pressure of the gas and V is its volume. 45,000 represents the internal energy of the system, which is basically how much heat it has. The answer is inverse proportion, and the reason is that the equation is similar to the conservation form of the equation for inverse proportion. You see, with the conservation form, the constant is isolated, which is what we have here. If the number is isolated, the number part is isolated, then you're dealing with the conservation form. And on the left side, we have P times V, which matches the form Q2 times Q1. The conclusions that we can make: scaling the pressure by a factor, that means multiplying the pressure by a number, forces the scaling of the volume by the inverse of that factor. That means that the volume gets divided by that number. So if you double the pressure, you divide the volume by 2. If you bring the pressure up to 3 times its value, then volume goes down to 1/3 of its value. 10 times the pressure, 1/10 of the volume. Also, if you bring the pressure down to half its value, then volume will double. So pressure gets divided by 2, volume gets multiplied by 2. And the product of pressure and volume is the internal energy of the system, which is 45,000 joules. Again, that comes from the conservation form, which is basically what this says. The product of pressure and volume, that would be PV, that's equals the internal energy of the system, which is 45,000 joules. 45,000. Here's problem number 4. Identify the relationship between the quantities age of Mario and age of Maria in the formula below. What conclusions can you make based on this classification? Mario's age minus Maria's age is 2.5, with 2.5 years representing the difference between their ages. The answer is direct superposition. I let you justify that. This means an increase or decrease in the age of one of them is matched by an increase or decrease in the other's age, which of course makes sense. If one of them gets 2 years older, the other one gets 2 years older, and so on. And the difference between their ages is always 2.5 years, which is pretty much what this form of the equation says. Here comes problem number 5. Identify the relationship between the quantities, mass of medication, and the duration of administration of the medication in the formula below. What conclusions can you make based on this classification? M divided by T is equal to 3.2. 3.2 milligrams per hour represents the rate at which medication is administered. The answer is direct proportion. The equation matches the conservation form of direct proportion. This means that scaling the time by a factor forces the scaling of the amount of medication by the same factor. So if you administer the medication for twice longer at the same rate, 3.2 milligrams per hour, then the amount of medication that's given to the patient doubles, and so on. And it also means that the quotient of the mass of medication and the duration of administration is 3.2 milligrams per hour, which is what this conservation form says. Here comes the last problem. Identify the relationship between the quantities pH and pOH in the formula below. What conclusions can you make based on this classification? pH plus pOH is equal to 14. 14 represents the logarithm of the dissociation constant for water. And here's the answer. The relationship is inverse superposition based on the conservation form of the inverse superposition relationship. This means an increase or decrease in pH is matched by a decrease or increase in pOH, and vice versa. So if pH goes up by 2, pOH goes down by 2. If pH goes down by 1, pOH goes up by 1. And it also means that the sum of pH and pOH is equal to the logarithm of the dissociation constant for water, which is 14. Okay everyone, thank you very much for watching this video. In the next video, I bring everything together and we'll talk about how to establish relationships between two quantities in a formula.